Hello, everyone. So we have now AMC 12A number 24. This is actually a cool question, and I've seen something similar to this one in probably a while ago in one of the previous AMC 12 problems. If I can come up with that problem again, I'll just put in the description. You can check that out as well, because this is really common question as well, even though this was number 24. So what we are going to do, we're going to take the center. Let's read the question, right? So the circle has radius of r, so the middle guy, and then there is 12 smaller ones that is put it around. They are all tangent to each other, and we want to find the radius of this larger circle. So what we are gonna do, we connect the centers. They has to pass through the intersection, and then I will do the same thing with the next circle. And then if you connect their centers, they has to go through the center, the tangency point as well. And since we have equal circles, like the radius of the same like circles, then the entire 360 degrees will be equally spaced. So meaning that like if you just draw those triangles around, so you will get 12 of these. So then if you take the 360 and divide by 12, so you end up getting the angle like 30 degrees right here. At this point, the rest kind of slightly easier, I believe. So that will be 1, and this is R, and this is R, and then this is also 1 and 1. Since we have a triangle, we have like almost everything except the R. That's why we are interested, but we have an angle, which is a job for the law of cosine. So if I take the square of the segment that is opposite 30 degrees, which is 2, that will be 2 squared, is equal to the square of R plus 1. But we also have the square of R plus 1 right here. So I'll say 2 copies of this minus this side times cosine of the angle in between. So you will get 2 times R plus 1 squared times cosine of the 30 degrees, which is going to be square root of 3 over 2. Again, if you don't know this on top of your head, so you can make a right triangle, 36 to 90 triangle. So you can use that one to see. And since we have lovely R plus 1s are kind of common, so we can pull that as a factor. So that will make things slightly better. And then that will be 2 minus 2 times square root of 3 over 2. And this was given as 4. And if you simplify this and then divide by 2 minus root 3, and then we have the square right here. So the R plus 1 square is going to be like 4 over 2 minus root 3. And then if I multiply the top and bottom by 2 plus root 3, so you end up getting 8 plus 4 root 3. And then the bottom one will be 4 minus 3, which is 1, so there's nothing really left over. And then R plus 1 squared. And then at this point, we can take the square root, so you will get R plus 1 is equal to the square root of 8 plus 4 root 3. So this is kind of a bit challenging for maybe some of us if you really cannot see what's going on at this point. So since the question says the answer R has to be in this form, see, it looks like integer. If I subtract 1 from both sides, so you can say this is like 1 will be minus 1. That looks like maybe a C. And then the root A plus root B should be whatever we got from the square root of this mess. But if you cannot really just see what that looks like, maybe you can just guess the inside guy as like root A plus root B. And then when you square this, you're going to get whatever inside. So that's our right now guess, and see if this is going to help us, because that's always good to guess and kind of confirm if that's really the case. So that should be 8 plus 4 root 3. And if I expand this, you got A plus B plus 2 times square root of AB is equal to A plus, and then 4 root 3, I'm going to take this like same coefficient, like I'm going to take this 4 and then put inside for one of the 2's. So you will get 2 root 12. With that in mind, so irrational part should be the same as irrational. The integer part should be same to each other. So the A plus B will be 8. And then A times B has to be 12. And then I can take the b as 12 over a, so that should be a plus 12 over a is equal to 8. So at this point, you can go ahead and multiply this by 8 and then get a quadratic and so forth, that, which is okay. But at this, you can also guess those as well. So the sum of two things is 8, and the product is 12. So it looks like 6 and 2 does work. And then it doesn't really matter which order you have. So again, you can solve this quadratic if you want to. But with this integer, so 6 and 2, or 2 and 6. So then A is working. So then the answer has to be R is equal to root 6 plus root 2 comes from this expression. When you simplify, take the square root, because when you square this expression, you got this inside, and I subtract 1 from both sides, so you got the R. And then the A, B, C are given now. So the A is like, let's say 6, and then that's 2, and minus 1. So it is 7. And then if you kind of maybe don't like doing this way, there's another approach we actually can do this problem, which is something I'm gonna remind a property, which we have, special right triangles, right? But one of them is a 15, 75, 98 triangle that we don't see that often, but it is really common these days, I will say, because I've seen this kind of question a couple of times in the last 2 years. So what I'm trying to say, if I do connect this way instead, you will get a right angle triangle where the angle right here will be just 15 degrees. And then you got, this is 90 degrees. So this is 1, this is 1, this is R. So if you don't remember anything like 1575, 90, so let me just remind that first. And then I made this proof on that, so you can take a look at some of the videos that I made in the past. I can put it probably in the description at some point as well. So let's say this is 75 degrees, and then this is 15. In this triangle, the hypotenuse, let's say 4x, and the smaller leg will be root 6 minus root 2 times x. And then that will be, other one is root 6 plus root 2 times x. Again, if you did know this one, this problem will be way easier than the first approach, especially if you were not able to like get those integers 2 and 6 easily when you use the first approach. But let's now use this one. So like we have the triangle like this, right? So we have 1 here, and then this is R plus 1, and then this is 75 and 15. So the ratio was, the smaller leg will be root 6 minus root 2. The hypotenuse is 4, and then the larger leg, root 6 plus root 2 in 75, 15 triangle. So we can write the ratio. We just know the hypotenuse and one leg. So I'm going to write R plus 1 over 1. That's the ratio of the hypotenuse to the smaller leg. It has to be 4 over 6 minus root 2. And from here, so I can simplify this guy. So then R plus 1 has to be 4 times root 6 plus root 2 divided by, when you multiply this by root 6 plus root 2, you get just 4 by difference of square. And then R will be same as before. So the root 6 plus root 2 and minus 1. So I prefer the second approach in general, but the law of cosine is still good in this problem. But 1575 is really useful. So I hope that was clear. I'll see you in the next video.